All right, let's look at the homework 3.8, problem number 7. All right, so this is the Newton's law of cooling problem. All right, so we have a cup of coffee, and its temperature is initially 95 degrees Celsius. So which means that we know that initial temperature, so T sub 0 is equal to 95. Right? Then it's in a room whose temperature is kept at the 20. Well, so which means that the T sub S is equal to 20. Right? Then when the temperature is 60, its cooling rate is at 1 degrees per minute. All right, remember that the differential equation we were looking at was d capital T over dt. So rate of change of temperature is proportional to the difference between the temperature and the surrounding temperature, right? So in this case, we have, let's see, this is going to be equal to K, which we don't know. But when T is equal to 60, and the surrounding temperature is always 20, and this is going to be 1 degrees per minute. So, but it's cooling, so it's -1. All right. So if you solve this equation, we know that this is a 40K is equal to -1, which means that we can just divide through by 40 to find the K to be -1 over 40. All right, so we already found the K value, so therefore we know actually the temperature equation. Temperature function is equal to, all right, surrounding temperature, which is 20, plus initial temperature, which is 95, minus the surrounding temperature, 20, e to the K, which is -1 over 40, and raise it to the kth power. All right, so if you simplify that, this is just going to be 20 plus 75 e to the -t over 40. Right? So we set this guy equal to, so let's see, when its temperature is 60, then when does this occur? So we want to set that equal to 60. All right. Then we can just solve this equation. First, subtract 20, and then you're going to have 75 e to the -t over 40 is equal to 40. Right. Then we can divide through by 75. We get e to the -t over 40 is equal to 40 over 75. All right, so that's a multiple of 5, so it's going to be 5 times 8 would be 40, and 75 would be 115. All right, so it's 8 over 15. All right, so we can solve for t by taking a natural log. If you take the natural log and the exponential function cancel out, so you're going to have -t over 40 is equal to natural log of 8 over 15. All right, so therefore we can find t by multiply both sides by -40. That way we can isolate t, which is going to be -40 times natural log of 8 over 15. All right, so let's find that value. All right, -40 times natural log of 8 over 15. All right, so let's find this value. Hit enter. All right. So we got 25.14. So let's see, round it to 2 decimal places. So 25.14. So, right, this is about 25.14 minute. All right, so let's type this guy in. All right, so go to the here. All right, so we got the 25.14. All right, so let's check the answer. Submit for testing. All right, it came back and looks like we got this one correctly. All right, that's it. I hope that this was clear.